Well, hello and welcome to the XB-1 Supersonic Rollout. I have to say, today's a day I've been looking forward to for more than 6 years. And I'd like to start with a little bit of my own story. I grew up in Cincinnati, Ohio, and my grandfather, a World War II veteran, helped maintain aircraft in the Pacific Theater. And I was lucky. He lived just an hour away in rural Indiana. We got to play together virtually every weekend, building sandcastles, driving model trains, peddling vegetables from his garden. He taught me the values of hard work and of entrepreneurship. And it's hard to imagine the life I have today were it not for his formative influence. Fast forward a generation, and today I have a family of my own, 2 boys and a girl. And they too have a pretty special grandpa, a founder and an entrepreneur himself. But sadly, he lives 18 hours away in Hong Kong. The kids see him maybe once a year, and there's simply no opportunity to grow close. For many of us, this story may ring familiar. The barrier of time keeps us from connecting with the people in our lives who matter most. But what would happen if the time between my children and their grandfather were cut in half? What memories could we make? What lessons could be passed on from generation to generation? And what else could we accomplish? We founded Boom with these questions in mind. And from the very beginning, we've been driven by a singular mission: to make the world dramatically more accessible by building aircraft that are faster, less expensive, and more convenient. At supersonic speeds, cities rarely visited can become major destinations. You can cross an ocean, do business, and still be home in time for an evening with loved ones. Global leaders can convene in the same room to resolve a crisis. A donor heart could arrive in time to save a life. And our children can grow up in a world where nothing is foreign any longer. It has been more than half a century since we've had a mainstream speed up in air travel. But during this time, we've made incredible advancements in the foundational technologies for designing, developing, and building aircraft. We have advanced aerodynamics, new materials, and significantly more efficient engines. And today marks a historic milestone at Boom, as we have brought these technologies together for the first time to build a new generation of faster aircraft, of speed in service of greater human connection. And along the way, we have set the principles and the foundation, not just for the technical design of future aircraft, but how we approach our mission in general. We've established our principles of speed, safety, and sustainability without compromise. And we've begun to pave the path toward a mainstream supersonic future. Today, we stand here on the precipice of a new age of travel. And I am so proud to announce Supersonic is here. This is XB-1, history's first independently developed supersonic jet. Every feature of this airplane has been optimized for high-speed performance, and everything we've learned from the aircraft has directly informed the design and development of our Overture passenger airliner. Stretching 71 feet in length, its fuselage is designed for speed, minimizing drag and supersonic performance. Its carbon composite airframe retains its rigidity and strength even under the temperatures and pressures of high-speed flight. XB-1's delta wing balances low-speed performance for takeoff and landing with high-speed efficiency. 3 J85 engines designed by General Electric propel it to breakthrough supersonic speeds. Its ergonomic cockpit was designed with our test pilots in the loop, with hundreds of hours of human factors analysis and usability testing. Its nose, where the air first meets the airplane, has a refined shape to generate the precise vortex flow to ensure stability across a wide range of airspeeds. I'd like to introduce 2 people who have helped us tremendously along the way. LinkedIn co-founder and early Boom investor Reid Hoffman, and Lockheed Martin former Chief Technology Officer Dr. Ray Johnson.
Boom is the first private company to design, develop, and build supersonic travel. XB-1 sets the foundation for Overture's development. We are now back to the modern future, where supersonic travel is something that everyone can enjoy. The XB-1 rollout is where supersonic travel begins.
The XB-1 rollout is a significant accomplishment for Boom. It represents the ability to design, manufacture, and soon fly a supersonic aircraft. Those capabilities and that experience will port directly to the development of Overture.
In the early days, people thought we were just plain crazy for taking on a challenge so audacious, especially in an industry that hasn't seen a new commercial aircraft startup in nearly 100 years. But hard, important problems are a magnet for great people. At Boom, I'm incredibly proud that we've assembled a team of nearly 150 people with experience from places like Gulfstream, SpaceX, NASA, and Amazon. We've done hard things before, and our aim for Boom is to be the place where the most talented innovators on the planet can be inspired to do the best and most meaningful work of their careers. XB-1 is a product of this team's tireless effort, of tens of thousands of hours of design, development, and meticulous testing. We have a saying at Boom: you have to be naive enough to start, but wise enough to finish. And we've overcome so many setbacks and roadblocks along the way. XB-1 represents a breakthrough in high-speed efficiency that will change the way we all fly. And to build this aircraft, we're standing on top of half a century of progress in fundamental aerospace technologies. We've gone from aluminum to carbon fiber, from wind tunnels to computer simulation, and we've completely changed the way we design and build jet engines. XB-1 brings these technologies together, and ultimately, it will change the way we experience the planet. I'm incredibly proud of the team that has made this happen, and when XB-1 takes to the skies next year, it will be history's first independently developed supersonic jet. I would love for you to meet some of the talented innovators that have made XB-1 possible. Let's start with Greg Crowland, XB-1's chief engineer.
Thanks, Blake. I'm the chief engineer of the XB-1 program, and I lead a team that's responsible for the design, development, and performance of our demonstrator aircraft. As an airplane guy, I joined Boom to help solve a challenge that's persisted in the 75 years since the Bell X-1 first broke the sound barrier: affordable and sustainable supersonic travel. If these models look fast, it's because they're designed to be fast. They'll operate quicker than the speed of sound. But that speed doesn't come for free. The faster the aircraft travels, the more drag it experiences. You can offset this with greater engine thrust, but that comes with increased fuel burn and therefore cost and emissions. At Boom, we aim to create a sleek, lightweight design that minimizes drag to the greatest extent possible, and therefore cost and emissions. In the 60 years since Concorde was developed, there have been several key advancements in technologies that make this possible: aerodynamic analysis, strong, lightweight materials, and efficient propulsion. Aerodynamics present the greatest challenge in achieving a successful supersonic design, and that is meeting your performance, handling, and efficiency goals while ensuring safe operation at the low speeds required by takeoff and landing. Our aircraft is dominated by design features that enable supersonic flight, specifically the long, slender fuselage, narrow, highly swept wing, and aggressive inlets designed to slow the oncoming supersonic air to the subsonic speeds that the engines require. All of these features, however, tend to have detrimental effects on low-speed flight characteristics. For that reason, many iterations are required to close on a design that enables safe and efficient operation at both high and low speeds. Concorde engineers had to solve these problems by creating designs with pencil and paper and evaluating those designs through extensive wind tunnel testing, which is both costly and time-intensive. Today, using advanced fluid simulation, high-powered computing, and digital design tools, we're able to reduce the iteration time from months to days. And while it's still important to validate our designs through wind tunnel testing, computer simulation has enabled us to reduce that effort by orders of magnitude. Next, XB-1 is primarily constructed of carbon fiber composites. These materials have several key advantages over metals commonly used in the aerospace industry. First, you're able to create large parts that are easily molded to the complex shapes that our aerodynamic design demands. Second, you can then tailor those parts to be strong in the necessary areas and lightweight in the others. And third, these materials are not as susceptible to the expansion and contraction associated with the temperature changes that are experienced during supersonic flight. By contrast, Concorde, which was an aluminum aircraft, grew by over a foot at max speed, and the SR-71 leaked fuel on the runway until its titanium skins could come up to temperature and seal the tanks. By using carbon fiber composites, we all but eliminate these concerns and therefore reduce structural complexity and the associated weight. Lastly, XB-1 is powered by 3 J85-15 engines that produce over 12,000 pounds of thrust. These engines have been ground tested with today's sustainable alternative fuels, and compared to the baseline set with the standard petroleum fuels, performance with these sustainable alternatives exceeded our expectations. As the first privately developed air-breathing supersonic aircraft, the objective of XB-1 is to bring these technologies together into a harmonized design, to solve the complex, difficult problems associated with new aircraft development, and to develop the tools and processes that will carry forward to our commercial program, Overture. But most importantly, it's driven the creation of a team that can solve complex, multidisciplinary problems across the design, build, and test phases of new aircraft development. I am incredibly proud of the team that we've assembled and what they've accomplished with our plane, XB-1. To tell you more about the build of the plane, I'm going to introduce you to Mike Jagaman, Head of Manufacturing.
Thank you, Greg. I'm Mike Jagaman. I lead the manufacturing of XB-1. The build process of an aircraft is considered from the very earliest phases of design. As Boom's 7th employee, my job was to bring advanced manufacturing technology to the design process. I worked closely with Greg's team to make sure that our designs were producible and manufacturable with the available technology. We built our team with a few fundamental philosophies in mind. First, get it right in design. 80% of an aircraft's cost is locked in the design phase. Second, plan early and plan often. You cannot start design reviews too early, nor can you have too many of them. Manufacturing feedback during the design process makes for a better final product. And third, don't wait until tomorrow to solve a problem. If a challenge arises, do not kick that can down the road. As I tell the team, don't wait until later to fix it, because later never comes. These philosophies help us save time and cost at every point along the way. I like to say that building an airplane is like eating an elephant. You take it one bite at a time. We built up XB-1 systematically by breaking each large component into subassemblies. Let's take the forward fuselage for example. It consists of the cockpit, systems bay, and landing gear bay subassemblies. Each of these large assemblies was built up separately and installed into the airframe when complete. We use high-precision metrology tools like laser trackers and measurement arms. These tools allow us to hold measurements within the width of a human hair. With our processes and tools combined, structures like the forward fuselage came together with a high level of efficiency and accuracy. Throughout the build, we're also testing to burn down risk and maximize safety. We pushed components like the nose landing gear, wing structure, and vertical tail to their limit loads, meaning they successfully met requirements for strength and durability under the most extreme flight conditions. The wing structure, as an example, can carry 60,000 pounds of load in flight. And for other parts, like the cockpit, we verified the design by bringing in the pilots when it was just a skeleton. In doing so, we ensured it was ergonomically shaped just for them. Everything from rudder pedals, safety harness, and instrument layout is optimized for their access and visibility. At every opportunity, we made a point to be smart about how we developed each component. Thanks to our partnership with Stratasys, a global 3D printing leader, we can both rapidly prototype and build flight hardware right here in our hangar. What used to take tens of thousands of dollars and weeks of time has been reduced to an overnight task at a fraction of the cost. We can start a print job at the end of the day, and that part will be ready to be tested or assembled the next day. Whether it's the thousands of drill blocks or the actual flight hardware that we have produced, 3D printing has saved us valuable time and money. At Rollout, we're celebrating the handoff of XB-1 from the design and build phase into the test phase of the program. I am so proud of this team's hard work and dedication. We are so excited to see XB-1 fly for the first time.
The Boom team's been working extremely hard over the past couple of years to design and build XB-1. We won't know if the aircraft performs to expectations until we actually fly it. The role of the flight test team is to take XB-1 Supersonic as safely as we possibly can. We've got a number of tools to do that. One is a build-up approach, where we take what we've learned from the previous flight and plan the next flight using that information. We'll start with a small, well-understood part of the envelope and build from there. Another tool that we have is the simulator behind me. The simulator takes the latest information about XB-1 and gives the pilot a preview of how the aircraft's going to handle in flight. But it's not just the pilots that are going to make XB-1 safe. We're supported by a team of maintainers and flight test engineers. We'll include them in the rehearsals by linking the simulator to the control room. Any pilot will tell you that a simulator can only represent the real world so well. In order to get a real world flavor prior to first flight, definitely I will fly high performance aircraft like the F-5 and F-104. While not a perfect simulation, they'll let us hone our skills prior to the first flight.
The simulator has two primary purposes. The first is that of an engineering design tool, and the second is that of a training tool for both the pilots and the control room. We built this simulator here in order to test and get an early preview of the displays, the switch layout, the flight controls, and the view the pilot has out of the nose of the aircraft. This is version 2 of the simulator for Boom. This is the highest fidelity version of the cockpit outside of XB-1 itself. That allows us to run full rehearsals with the entire control room and get a true feel for how the entire envelope expansion will go for XB-1 throughout its entire envelope.
As the chief flight test engineer, I'm responsible for keeping Doc and Duff safe in the aircraft by leading the control room team on the ground. Just like you've seen on NASA spaceflight missions, we have a control room to help ensure the safety of our aircraft. The difference is the engineers in our control room are the same ones who designed and built the aircraft, so they know it like the back of their hand. I'm currently taking our team of 30 engineers through a comprehensive training and rehearsal program. The objective of this is to make sure that they're prepared for safe flight tests and everything happens efficiently. By the time we get done with the training program, they'll have probably seen the first flight over 100 times. During the training program, I'll give them different scenarios where they'll have to respond to a problem and come up with a solution. As an example, I may increase the temperature on a flight critical component of the aircraft beyond its maximum value. They'll have to figure out how to safely recover the aircraft. By the time we're done, the engineers should be ready for just about anything, ensuring that we have a safe first flight that goes exactly as planned.
One of the reasons that we train so much is that XB-1, like any supersonic aircraft, has some unique handling qualities. In order to be efficient at high speed, XB-1 has a narrow wingspan. And one consequence of this is that on the approach to the runway, XB-1 is pretty fast and it has a pretty high angle of attack, meaning that the nose is well above the horizon. This can make it difficult for the pilots to see the runway. The way Concorde managed this challenge was to mechanically droop the nose to give the pilots a direct view of the runway. For XB-1, we have 2 cameras mounted on the nose gear. These give the pilot a virtual view of the runway. The advantage is that they get all the cues that you get from the direct view, but without the mechanical complexity.
Throughout the entire program, the role of the test pilot is that of the skeptic. It's our job to constantly challenge and question every engineering design decision in order to ensure we have the safest aircraft possible by the time we enter flight. As we enter engine runs and taxi tests, however, we'll start to trust the aircraft and believe that it's truly safe to go fly. At this point, that crucial role of the skeptic must be filled by someone else. We will purposely transition that role to that of the chase pilot, the other test pilot in the program that will be airborne with us on every single mission. They will help us safely execute the entire envelope expansion.
When it comes to decision making, our varied flight test experiences and backgrounds is one of our strongest assets. Between the 3 of us, we've attended 2 different test pilot schools, We're in 2 different branches of the military, and we've flown everything from helicopters to high-performance aircraft. When we have to make a decision, we'll sometimes approach it from different perspectives, but always with the same fundamental mindset of maximizing safety and minimizing risk to the program. It'll all come together in the desert over Mojave in the very near future. The first flight of XB-1 will be a historic event, just like the historic first flight of the Bell X-1 many years prior. We're looking forward to accomplishing that milestone and can't wait to share it with all of you in the next year.
I'm Julie Volk, and I lead programs and operations for XB-1 and Overture. As Blake mentioned, our goal is to build a supersonic airliner that carries passengers across the world. So why build a test aircraft with only 1 seat? Well, it's pretty common in large advanced airplane programs to use a test aircraft. The XB-1's a one-of-a-kind aircraft designed, built, and optimized to gather learnings for Overture. We kept this top of mind as we developed the program. We used advanced engineering and state-of-the-art materials, manufacturing, and assembly processes. There are 4 key ways XB-1 supports Overture: our processes, design, sustainability, and relationships. But let's talk about our processes first. We built an aerodynamic analysis tool that we use to optimize our performance across the flight envelope, including supersonic and subsonic conditions. We will continue to refine our engineering tooling as we go into the flight test program in Mojave, where we will calibrate our inlet design and verify its performance, optimize our flight control augmentation system, and validate the aerodynamic analysis tools that I described earlier. Next up is supersonic design experience. What is unique to designing a supersonic aircraft is that every engineering decision has a very strong interdependency on another part of the plane. For example, when you design the shape of the plane, it directly applies constraints to the systems within. And now we have an engineering organization that's proficient in supersonic design and understand the multifunctional impacts of every engineering decision. In regards to our sustainability initiatives, we prioritize the design that would maximize its fuel efficiency. Just like in your own car, an aircraft's fuel efficiency directly translates to how sustainably it operates. We're using the learnings from XB-1 flight test program in Mojave to ensure Overture is as efficient as possible. From day 1, we will have a net zero carbon flight test program. We've now shown to the world that we can turn a paper plane into a physical build, and this demonstrated ability has opened doors for Overture partners, suppliers, and customers. We've refined the perfect balance between startup creativity and advanced industry innovation. We're smarter, faster, and more connected as a team thanks to the XB-1 program. We take great strides to learn from every aspect of history, and we've sought advice from groundbreakers that came before us. One great example of that is NASA's space program.
We at NASA were in pursuit of making space more readily available. We sent so many people to space in those years aboard the space shuttle. That's what Boom is about to do with the rollout of XB-1 today. Boom is going to pave the way for supersonic airliner travel.
And Boom is about to bring out a prototype that should fly next year and put us on a good path, a good trajectory toward eventually getting to Overture and supersonic flight around the world for people like you and me.
It's going to revolutionize air travel, and therefore it's going to be an unforgettable experience for all of them.
It's not a mock-up, it's not a drawing on a board, it's actually a flight vehicle.
Over the space of 18 years as a space shuttle astronaut, to work with a lot of very highly qualified, very experienced and technical people, and I see the same thing at Boom that I got to see at NASA over all those years.
I found the same level of enthusiasm, dedication to mission that I had seen in my Marines for 34 years and also at NASA during the 20+ years that I was privileged to be a member of the NASA family. It was focus on mission, dedication to doing something that was going to make life better for people here on the planet, and that's what really excited me about Boom.
as you can tell, we love airplanes and the technology that makes them possible. But our pursuit of speed runs deeper. It's about how we as humans experience each other and the planet. When airplanes fly twice as fast, we'll all be able to experience more of the world's people, places, and cultures. All of us have a story about how removing the barrier of time will allow us to connect better with the people who matter most. And for each of us at Boom, there's a personal reason that drives us forward towards our mission. I'd like to introduce a man equally passionate about how airplanes are built and how they improve our lives, our Senior Vice President of Overture, Brian Durrance.
Thank you, Blake. I've spent my entire career developing subsonic jets, but supersonic has always been a passion of mine. I grew up on a farm, and I have many distinct memories of stopping to watch aircraft as they flew over. Flight has always fascinated me. From when I was very young, I knew I wanted to design and develop new, faster aircraft. Boom is a chance to make that happen, something I've wanted to do my entire life. I've been in the industry several decades now, and yes, I still stop to watch aircraft fly over. But nowadays, I like to look around to see who else is staring at the sky. It is a great indicator of who the true aircraft people are. And I must say, I have caught Blake craning his neck more than a few times. Thank you for joining us today to share our vision for the future of travel. We will talk about Overture's development and what it would be like to travel supersonic. But first, I'd like to offer some historical perspective. Blake is right. Now is the time for a supersonic renaissance. But we're not the first people to strive for a better, faster way of travel. 60 years ago, the engineers behind Concorde created a technological marvel, and their vision was strong enough to overcome the limitations of 1960s technology. And to tell us more about Concorde's legacy, I'd like to introduce Chief Concorde Pilot for British Airways, Mike Bannister, and author Lawrence Azarat.
Ever since man first flew, ever since the Wright brothers took to the air, people have wanted to travel faster and faster. Concorde was the epitome of supersonic travel, the ability to fly at 1,350 miles an hour, to arrive before you left, to travel faster than the Earth rotates. Sadly, Concorde stopped flying in 2003, but I've always believed there would be a supersonic successor. My glass is always half full, and I've been looking forward to the opportunity to see a supersonic airliner take to the air. And the Overture will be that airliner. It is so exciting.
It's a symbol of what we can do when we dare to dream mighty things. When ingenuity, determination, creativity, and science come together.
With the rollout of XB-1 today, we're taking another major step towards a supersonic airliner taking flight and flying passengers at twice the speed of sound or more all over the world. It's a really big deal, and it builds on Concorde's legacy.
What Overture is doing is not just building on the Concorde legacy, but building on everything that we've learned since the Concorde legacy. And looking at the challenges around us, that travel doesn't have to be the way it is now, that we can do better. We can build a better solution.
Concorde is a story of an audacious vision, of a journey started but not yet completed. Limited by the technology of its time, it flew on only a few routes and only at stratospheric fares. It never changed the way most of us traveled. But half a century later, the conditions have arrived for a renaissance in speed. Overture is the first aircraft in a new generation of travel. The first in a whole series of aircraft, which will have progressively longer range, higher speed, and lower fares. Here is the future I believe in, a future in which you can get anywhere on the planet in 4 hours for just $100. A world in which the fastest flight is also the cheapest, and there's no reason ever to board a slow plane. That is what we mean when we talk about making the planet dramatically more accessible. Along the way, we've been fortunate to have some great partners who shared our vision even in the early days and were willing to throw in with us to make it a reality. Japan Airlines is one of those partners. With Overture, Tokyo will be just 4.5 hours from Seattle. I'd like to introduce Yoshihiro Ueki, who as chairman of Japan Airlines shared our vision and championed it from the earliest days. We owe a debt of gratitude to him and his team at Japan Airlines.
Hello, I'm Yoshihiro Ueki, Chairman for Japan Airlines. Japan Airlines has had the unique privilege of witnessing up close numerous milestones that Boom has achieved, and we are pleased to witness today this historic event of the XB-1 rollout. We see Boom's successes to date in part because of their team's incredible vision, exceptional skills, and commitment to safety and quality. We continue to provide our knowledge and experience in support of the program, and it has been a privilege to play this role and work together with Blake and the entire Boom team. We imagine supersonic travel bringing significant value to the aviation industry and to international passengers in particular. Boom is empowering the next era of travel through supersonic technology, and we are excited to embark on this journey with them. Congratulations, Boom, on achieving this milestone today.
With partners like Ueki-san and Japan Airlines, we can do more than just build faster airplanes. Our vision is a supersonic future without compromise, where we can achieve speed, safety, and sustainability. Those are the principles that guide us. But speed is at the core of what we are building. When London is just 3.5 hours from New York, you can cross the Atlantic, do business, and be home in time to tuck kids into bed. When Sydney is 8 hours from Los Angeles, Australia becomes as accessible as Hawaii is today. And when Montreal is 4 hours from Paris, no relationship need be considered long distance anymore. Speed allows us to do more, to see more, and no destination will be out of our reach. Now I'd like to hand it back to Brian to talk about how we're building safety into Overture from the ground up.
Speed is what motivates us, but safety is always at the forefront of our minds here at Boom. It is part of our DNA and influences every decision that we make, from engineering design and employee wellness to the health and well-being of our future passengers. As you know, regulation and certification can drive a tremendous amount of requirements to airliners, but those are minimums. Our objective is to exceed those expectations and provide additional features not readily available on other aircraft. We are thinking of ways to make flying on Overture a restorative experience, allowing our passengers to arrive refreshed and energized.
Thanks, Brian. Well, that brings us to sustainability. At Boom, we believe that travel is a fundamental human good, and a planet in which we can go more places more often is a better place to live. However, we don't want you to have to worry about the adverse effects of travel on the planet. And so we challenged ourselves to make Overture 100% carbon neutral from day one. The good news is there's a new generation of jet fuels, fuels made from carbon that was removed from the atmosphere. And we're designing Overture to be the first airliner built from the ground up to run on 100% sustainable alternative fuels. To tell you more about how sustainability is built into everything we do at Boom, I'd like to invite up our sustainability team and some of our key partners.
At Boom, we're taking an all-encompassing approach to vehicle design. This is everything from how we develop and test our aircraft, to how we design our production facility, to what we're doing for the end of life of Overture, the recycling process, and also making sure that we're setting our airline customers up for success in terms of minimizing community noise impacts and ensuring that Overture is a zero carbon aircraft.
It's a company that's led by folks that have grown up in an environment that's very, very respectful of sustainability. So it's been refreshing to really see a company that embraces sustainability.
From day one, Boom has understood the opportunity that their products represent in demonstrating the viability of sustainability in air travel. They've incorporated the ideas and concepts of sustainability into the Overture program, and most recently they have pledged that both the flight and ground testing of the XB-1 will be carbon neutral.
We've built relationships in the sustainable fuel supply chain, including with Prometheus Fuels.
Prometheus Fuels removes CO2 from the air, so that when you use these fuels, they don't add any CO2 to the atmosphere, they don't contribute to global warming. truly renewable fuels. And our goal is to make the future of supersonic flight carbon neutral.
The renewable energy is there, and we now have a path via which we can use sustainable alternative fuels.
So at Boom, we are building the world's fastest airliner, and there are unquestionable benefits to speed for society. But we don't think speed has to conflict with sustainability. These two things can be compatible. We enjoy the benefits of speed, but we're also making sure to be good stewards of the planet at the same time.
Overture will set a new standard for travel and change the way we think about distance. We're looking forward to flying our first passengers within the decade. And to get there, let's talk about Overture's roadmap. For years, Boom has been a two-aircraft company. As XB-1 was being tested and developed, part of our team was working on Overture's conceptual designs. And when XB-1 begins flight testing next year, the Overture team will be conducting wind tunnel testing to validate those designs. And as we finalize Overture's airframe, XB-1 will be breaking the sound barrier. By 2022, we'll be breaking ground on Overture's new production facility, where the first aircraft will be built and rolled out in 2025, followed by an extensive test and certification program. With many exciting technical developments to come, we are eager to bring the benefits of supersonic flight to market and look forward to seeing you on board.
To get there, we've been working behind the scenes with Rolls-Royce for more than 5 years to define and refine the ideal propulsion system for Overture. To tell you more about our partnership, I'd like to introduce Simon Carlisle, Strategy Director for Civil Aerospace at Rolls-Royce.
Hi, my name's Simon Carlisle and I'm Strategy Director for Rolls-Royce Civil Aerospace. It's a great occasion for Boom and we're really excited to be able to see a new aeroplane fly. We believe at Rolls-Royce that our combination of experience borne out through Concorde, our unique technologies and our commitment to a sustainable future uniquely position us to help Boom develop this aircraft in a way that can bring real advantage to aviation and give passengers optionality around supersonic travel. Sustainability is a really big issue for aerospace at the moment, with lots of companies focused on how they can improve the amount of CO2 that is generated by our products. At Rolls-Royce, we're really committed to having net zero by 2050 for all our products, both existing ones and the ones in the future. And that will be achieved through a combination of different activities, through the application of new efficient technologies, through the use of sustainable aviation fuel, and through the use of other power sources to reduce the reliance on carbon fuels. Supersonic travel can be part of that value proposition that aviation offers to the globe in general, and we believe there's lots of benefits that can come from the development of the technologies associated with supersonic travel. So my congratulations to everyone at Boom. I'm really excited to see XB-1 fly. This is a big deal. It's always a big deal in aviation when a new aeroplane flies. I look to the future, take enormous pride in what you've achieved so far. There's lots of hard work to come. Rolls-Royce is going to be here to work with you through that. Thank you very much.
Thanks, Simon. We're thrilled to have you and Rolls-Royce as partners. When passengers hear about Overture, the first question they ask us is, what will it be like to fly supersonic? High-speed airplanes fly at higher altitudes, and Overture cruises at up to 60,000 feet. At those altitudes, you're flying above most weather and turbulence, giving you a smoother ride. At the same time, you'll experience a unique view. You can see the darkness of space above and the curvature of Earth below. Today, flying can be so stressful, but we're designing an Overture to give you a sense of tranquility from the moment you step aboard. During your flight, you'll experience an environment crafted for productivity and relaxation. Over the next few years, as we bring Overture to life, we'll share more about the passenger experience. Supersonic flight holds immense promise for airlines, where it offers a new way to connect the world. But it will also be transformative in other areas. Imagine what it will be like when our government and military leaders can traverse the planet in half the time, when our diplomats can resolve crises in person, where close relationships with far-flung peoples can foster peace and understanding. I'm excited to share the work that we've started with the United States Air Force to bring a supersonic transport capability to the US government. I'd like to introduce General Ryan Britton of the US Air Force to tell you more about our collaboration.
Hi everyone, I'm General Ryan Britton, Air Force Program Executive Officer for the Presidential and Executive Airlift Directorate. The United States Air Force has always been a worldwide leader in driving technological advances for both government and commercial use. Today I am excited to discuss our newest collaboration with Boom Supersonic to explore the development of a supersonic executive transport for the Presidential and Executive Airlift Directorate. I'm standing today with my deputy, Mr. John Sly.
Boom is the perfect example of the American ingenuity that drives the economy forward through technological advances and also opens up the potential for a new generation of military executive aircraft ahead of our competitors on a much faster timeline.
Supersonic travel cuts flight times in half and makes it possible for our American diplomats and executive leaders to connect more frequently in person with greater access to foreign leaders, quicker responses to emerging crises, and more frequent attention to diplomatic missions. On behalf of the United States Air Force and the Presidential and Executive Airlift Directorate, we look forward to working with Boom to explore the future of supersonic capabilities, shrink the world, and to help give the United States a competitive technological advantage.
Thank you, sir. It's an honor to partner with you and the United States Air Force to bring Overture to our country's leaders. And I'm proud to bring the power of speed to our nation. Not that long ago, supersonic airliners were relics to be found only in museums. But today, we are breathing new life and new purpose into speed. Remember, it's not about spending less time on airplanes. It's about the trips not taken or even imagined today. The need for speed is alive and well. And now, we turn to the skies for a future of enduring supersonic travel. Are you ready?